Hi, I'm O. Today I would like to share with you a practical example on axial load estimation, especially for columns in a reinforced concrete building. There are few methods that we can use to determine the axial load for column, such as area method and detailed analysis from beam reactions. Whichever methods used, designer need to make sure that the axial load is carried down from roof to lower floors and later to the foundation. These videos only shows the estimation of axial load for column in a reinforced concrete beam building using area method. I will use a two-story reinforced concrete residential building to demonstrate how the estimation of axial load using area method be conducted. These are ground and first floor planes. This is the roof plane. If you notice here, notes on the elemental sizes and loadings are given. This is typical elevation for the building. The floor to floor height is 3 meter and the height of stump is 1 meter. In order to determine the axial load for the column of interest using area method, we need to identify the area that could contribute loadings to the column. This is a rough estimation where we make assumption that a floor panel that is supported by 2 columns at the right and 2 at the left would divide its area into half for these columns. For instance, by looking at grid line A, we can place a divider in between the 2 columns, say grid A1 and grid A2, and between columns A2 and A3, and so on. We can also place a divider in similar way for grid line B and C. This process will be more tricky if you have irregular arrangement of your column positions. Of interest can be identified, such as for columns at the 4 corners of the building, area that contribute to columns at perimeter of building, areas that contribute to the internal columns. This is the overall distribution of floor area to all these columns. Now we can determine the axial load for each of the column. For example, I will show you on how to estimate axial load on column grid A1. Information retrieved from the structure key plan are elemental sizes and loads. Remember, the process to determine the axial load for a column is a top-down process. We need to determine the axial load from the roof down to the stump. In this building, there are 2 columns and 1 stump at grid 1A. We can start to estimate the axial load from column from roof to first floor. This includes slab load where the GK and QK from slab are multiplied with the identified contributing area. For slab surf weight, one need to multiply the volume of slab to unit weight of concrete, say 24 kN per meter cube in this case. The axial load in kilonewton shall be obtained. Also required, we need to know how long is the uniformly distributed load on the beam that contribute to the column. For instance, referring to the area of interest, only beam length half of 3.6 meter at grid line A and beam length of half of 4 meter at grid line 1 are contributing loading to the column. Axial load from beam surf weight can be obtained from multiplication of beam volume with the unit weight of the concrete. Column load is another load to consider. Column surf weight can be obtained from multiplying the volume of column, specifically the cross-sectional area, multiply the length of the column, and multiply the unit weight of the concrete. After we estimate all the necessary loadings, the design load can be obtained by applying factors recommended by Eurocode 2. Similar process can be applied to other column, like column from ground to first floor, and for stump. Remember, the axial load that we have determined only receive loading for a floor. The column at the lower floor always takes the loads from the upper floors. So here we list down all the axial load we have determined earlier. Then we will determine the cumulative design axial load for each of these columns. Since there is no other floor above the roof, the axial load that carries by the column from first floor to roof will be 31.5 kN. For column ground to first floor, the axial load for the column, aside from the floor itself, at the 6.3 kN, the column also takes load from upper floor, which is the roof, for 31.5 kN. Therefore, by summing them up, this column is taking axial load of 117.8 kN. Next, the stump will need to take up the loadings from all the above floors, therefore end up with 198.4 kN. You will see that the highest axial load imposed on the stump. To wrap up, area method is one of a very useful but gives only rough estimation of loadings for columns. Designer may need to use the method when the foundation information is needed before the detailed calculation comes. Designer need to always make sure that the axial forces obtained from this method to be double-checked once the detailed calculation is ready. I end my video on estimation of axial load using area method for reinforced concrete column. See you in my next video.